Okay, so I'm Dr. Jamie Blanche, and to give you a bit of an overview of what I've been working on is, so my research career starts in 2015, and it was at Heriot Watt University, and I was doing my PhD on using radar to tell what the pore contents of rocks are. So rocks are porous, and they can have liquids and fluids, air, oil or gas in them. And the PhD was all about using the radar as a non-destructive, non-invasive method of telling you whether you've got these various fluids within your rock. So I've taken that research and I've adapted it more recently so that we can use the same radar system in conjunction with autonomous systems or robotics, so that we can use that system to detect changes within the operating environment, be that ground integrity or be that visibility during the operational environment. So I've taken the FMCW radar research that we had applied again to geomaterials during my PhD and then applied to robotics during my PDRA research. And my future direction with this radar is I'd like to go back to the geomaterial analysis, because there have been two very, very interesting aspects of the radar with the geomaterials, and I think they're very topical. The first one is detecting hidden threats, or detecting, again, what the pore contents of those rocks are. So from my angle, I would like to actually marry the edge sensing of the FMCW with what is, in the largest strategic sense, a cyberphysical architecture or system. So what does that mean? That means using the edge sensing to inform AI and machine learning based algorithms that are linked with the cyberphysical system. And so you can have real-time understanding of what's happening in the subsurface. So for petroleum industry, carbon capture and storage, and the upcoming hydrogen economy, these are going to be really important because they will give you a real-time, up-to-the-minute understanding of what's happening underground. Is my hydrogen staying where it should in its storage aquifer, in its storage reservoir? Is water staying in the aquifer? Are hydrocarbons leaking from a reservoir, etc.? So the second angle to this is something I get very excited about, actually, is deformation. We have used the FMCW, the radar, to, again, non-contact, non-invasive, detect the effects of compression and deformation on a sandstone sample. Now the exciting part, the bit that I get excited about, is the fact that we've been able to predict, or at least inform, the imminence of failure of that loaded sample, which is very novel and unique. So yeah, my research application, I'm in the process of applying for a fellowship, is going to be developing that sensor to give us more of a early warning of failure on a loaded either sandstone or concrete block. So either way, this fits in well with carbon capture and storage, the need to meet climate targets for net zero, and also for civil infrastructure. If you can tell in advance that something is about to fail, then you have some sort of advance warning to set off alarms, etc. So that's my interest in my career so far. Okay, there's a couple, but I'm gonna just pick one of them, and that was the visit to ILL. So that's the Institute of Laulangeven. I may have mispronounced that. So that's a facility in Grenoble. It's a nuclear facility. So we had been using neutron bombardment of our sandstone samples during water injection to benchmark the FMCW. And in doing so, we were able to validate its sensitivity and findings. So thanks for watching. That's me in a nutshell, and I hope you find it as interesting as I do, although obviously I'm biased. Feel free to get in touch if you're interested in any of this research or anything that I've spoken about. My details will be flashing onto the screen somewhere around now.